Okay, question 7. It already is factored. There is no factoring to do. So we're already good with that. Horizontal asymptote remembers your ratio of your leading coefficients. Since it's degree 0 over degree 1, we can add in a 0x up top, and you get a ratio of 0 over 1, which is y equals 0. And that tells you your end behavior as well. And we can draw that in as a horizontal line. Now our vertical asymptotes come from setting our denominator equal to 0. And when I do that, I get x equals 3. And that's a vertical line. And that's going to give us our restrictions in our domain. So our domain will go negative infinity to 3, union 3 to infinity. X-intercepts come from setting our numerator equal to 0. If you do that, 5 equal to 0, that's not true, so there's none. You get your y-intercept by plugging in 0 for x, and so that'll just be your ratio of your constants. So that will be negative 5/3, which is right about here. Other points. So what you're going to need is other points to finish the graph here. And that's just because we don't know what's happening to the right of the vertical asymptote. We definitely know that this is going to approach the horizontal asymptote out and approach the vertical this way. So I need to plug in a point to the right of the vertical asymptote. So if I plug in 4, my output will be 5 divided by 4 minus 3, so that's 5 divided by 1. So we have the point 4, 5, and then you can just connect and make sure it approaches the horizontal and vertical asymptote. Now the next piece asks for where is it greater than 0. You can see the only piece where this function is above the x-axis is over here. Okay, so that starts at the vertical asymptote and goes to infinity. And then where is it below the x-axis? And that's, I'll color it in green now. That's all this piece. That's all negative outputs. So that's from negative infinity to 3. And then where does the function change sign? It only changes sign at this one at the vertical asymptote. So notice to the left of 3, all the outputs are negative, and to the right of 3, they're all positive. So at vertical asymptote, x equals 3. Okay, so now this next one, for number 8, the numerator can be factored to 2x plus 1 times x minus 2. The bottom, x plus 3 times x minus 1. Horizontal asymptote, again, comes from your ratio of your leading coefficients if the degrees match. So that's just going to be 2 over 1, which is y equals 2. And then that's also going to be our end behavior. So as x goes to negative infinity, f of x goes to 2. As x goes to positive infinity, f of x also goes to 2. So that's your horizontal asymptote. And then vertical asymptotes come from setting your denominator equal to 0. So when I do that, this gives me x equals negative 3, and this gives me x equals 1. And that also will give us the restrictions on our domain. So we put those in as vertical lines, and remember, your graph can't cross them, okay, or touch them. So those are your restrictions on your domain. So we're going to go from negative infinity to negative 3, union negative 3 to 1, union 1 to infinity. X-intercepts come from setting your numerator equal to 0. So 2x plus 1 equal to 0. If you solve that, you get an x-intercept of negative 1/2 comma 0, which is right there. And then your other one comes from x minus 2 equal to 0. So that's this point. So it also kind of helps us get a good idea of what our graph looks like. And our y-intercept is your ratio of your constants. So that'll be 0, 2/3. And then we're just going to need some other points to kind of fill in the gaps. So I would say go to the left of our vertical asymptote at like -4 and see what your output is. And that's about 8.4. So -4, 8.4 is up here. So that's going to give you this graph. In between, it kind of looks a little weird between -3 and 1. So if I plug in maybe 0.5, that's going to give me about 1.714. And so that just means that it's definitely growing. And so our graph is going to cross the horizontal asymptote. If you plugged in like -2, the output's -4. So that would put you about here. So then we know it's going to go like that. And then the other one we already know because of where the x-intercept is. Okay, so next it says, where is it greater than 0? You want to just look at all the values where it's above the x-axis. So all through here in green, through here, and then through there. So we'll say from -infinity to the vertical asymptote, then from the x-intercept to the vertical asymptote, and then from the other x-intercept through to infinity. It's above the x-axis. And then where is it below? Everywhere else. So from -3 until that x-intercept, and then from 1 to that x-intercept. And then where does it change signs? It's changing signs at our vertical asymptotes as well as our x-intercepts at -1/2 and 2, 0.